Let's solve this challenging trigonometric integral. We need to integrate sec²x times cosec²x with respect to x. Let's start by recalling what sec²x and cosec² actually mean. Sec² is 1 over cosine x, and cosec² is 1 over sine x. Therefore, when we square these terms, sec²x becomes 1 over cosine²x, and cosec²x becomes 1 over sine²x. This means our integral can be rewritten as the integral of 1 over cosine² times sine² dx. Now, here's where we can use a clever substitution. Remember that sine² times cosine² equals 1/4 times sine² of 2x. Therefore, 1 over sine² cosine² equals 4 over sine² of 2x. This means our integral becomes 4 times the integral of cosec² of 2x dx. We know that the integral of cosec² u is negative cotangent u. So 4 times the integral of cosec² of 2x is negative 2 times cotangent of 2x. Now for the final step, negative cotangent of 2x can be rewritten as tangent x minus cotangent x. This is a remarkable identity in trigonometry. To verify this is correct, we can differentiate tan x minus cot x. The derivative of tan x is sec²x, and the derivative of negative cot x is cosec²x. When we multiply these together, we get back our original integrand. Therefore, our final answer is tangent x minus cotangent x plus c. Here's a visual representation of the functions involved. The blue curve shows tan x, the green curve shows negative cot x, and the red curve shows their sum.